Good afternoon. My name is William Chen, Bill Chen, and I want to talk to you today about heterogeneous integration roadmap, paving the way for semiconductor and electronics resurgence. So I want to acknowledge my colleague, Ravi Mahajan from Intel, and Bill Bottoms from 3MTS, who are my colleagues. Together, we work on this presentation for the roadmap. So this is no ordinary time. The world, we have climate change, geographical conflicts, war in Ukraine. For economy, we see inflation, we see COVID-19. But the world of microelectronics and semiconductor is different. We see today the US, we have the Congress and the White House has signed off the US Chip and Science Act for fabs and packaging investments. TSMC, Intel, GlobalFoundries, TI, Samsung, Micron, together in their announcement, there's a $200 billion of investment. Similar scenarios are going on in Europe, Japan, Taiwan, India, Singapore, Malaysia, Vietnam, and other places. We have a renaissance in semiconductor and microelectronics, in science, in technology, in manufacturing development, and in research ecosystem. We have, in summary, we have an electronic system resurgence. So I want to talk to you about the roadmap. This was a press release from IEEE, the leading technology professional organization. It said on October the 10th that heterogeneous integration roadmap is a roadmap of the future of electronics, identifying technology requirements and potential solutions. And the primary objective is to stimulate pre-competitive collaboration among industry, academia, and government so that we can accelerate progress. This roadmap offers professions in our technology and research institutes. Now, if we just look at what we said over here, timing-wise, what it meant is that the White House announcement of $50 billion, they allocated a significant amount of money into the development in US on semiconductors, on manufacturing, and in manufacturing, actually, if you read the word, it means heterogeneous integration. And so what we are seeing right now is a group of money, a very large amount of money. I can't count $1 billion. Huge amount of money coming down. And we see that there's opportunity for us to solidify and building the future of the technology, especially in terms of research, in terms of education of the future workforce. So this roadmap, if you see on the left, this is a copy of the 2019 roadmap, and it is sponsored by Electronic Packaging Society, SEMI, IEEE, Electronic Devices Society, Photonics Society, and ASME, Electronics and Photonics Packaging Division. And the idea that we see is that it is time for us to look at the next of the ITRS. ITRS was closed down by Semi back in 2016 because they see that the future is going to be very different. So the heterogeneous integration roadmap is a roadmap that will take its role in guiding the future of the semiconductors and in packaging. So this is a roadmap that is driven by applications. So we identify 6 areas: high-performance computing data centers, mobile, medical health and wearables, IoT, automotive, and aerospace and defense as a driving force for this roadmap. It's a system-driven. And then we have interconnection components. Is that the building of the manufacturing for the systems of the future, which look at single and multi-chip, integrated photonics, integrated power electronics, photonics, MEMS and sensor, and also 5G. Then we have the cross-cutting topics that covers everything that every one of those items. So you can see materials and emerging materials, emerging devices, test, supply chain, security, thermal, and reliability. And then finally, the important part that we normally think about as advanced packaging, which is SiP and modules, 3D and 2D interconnect, wafer level packaging, and fan-in and fan-out. Now I put the most important item, most important technical working group in the last 2, co-design and simulation. Originally, we thought that we want to put co-design and simulation in one single chapter, driven by one single set of technical working group. And then after a while, we recognized that they need to stand by them as 2 separate working groups. So we are the microelectronics ecosystem. We have 23 technical working groups, and we are working together in collaboration. And we see that we will continue to grow in terms of coming up with new technical working groups as we go into the future. One of the technical working groups that is being planned, that is started working in developing the initial team will be in additive manufacturing. We see the additive manufacturing from design, materials, equipment will be very important into the future. So we see ourselves starting from the transistor focus, which was the ITRS, to the system focus, which is a heterogeneous integration roadmap. So we have these 6 applications, 6 markets applications as being the driven directions. Of course, they are all going to be empowered by AI, VR, and AR. So I have put down over here a definition of heterogeneous integration as defined as the integration of separately manufactured components into a high-level assembly, such as chiplets, SiPs, and modules, that in the aggregate provide enhanced functionality and improved operational characteristics. This is actually my favorite cartoon. At the 2020 ERI conference, Professor Philip Wang at Stanford University, and he is also the TSMC chief scientist, he delivered a presentation that's called "The Future is System Integration." He illustrates how the semiconductor research is different from the system research. So he said that it is like going through a dark tunnel when all that he was doing is to say how do we miniaturize into the next set of nodes to a bright future where you could see the broad and broader areas for research. So this is the electronics that's driving heterogeneous integration. You could see that we're looking at 2021, $510 billion of semiconductors. They'll go to $615 billion on semiconductors. You see the different application areas. And this is another way to look at our supply chain. And this is a slide from Semi that shows $2.5 trillion of electronic supply chain projected to go to $4 billion at the end of this decade. This is a presentation by DARPA and Gordon Keeler at DARPA. He showed the 4 directions for heterogeneous integration. This is AMD's chiplet strategy implementation. Now, in August, Pat Gassinger, Intel CEO, gave a talk at the Hot Chip conference. In this 1-hour talk, he said Moore's law is alive and well. Then he also showed the crucial new role of advanced packaging, continuing the Moore's law into the future. And he highlighted Intel's packaging technology portfolio applied to chiplets in Intel's component products. So if we look at that, he is very much talking about the future of advanced packaging, future of heterogeneous integration in continuing the direction of Moore's law. This is Intel Ponte Vecchio chiplets package for the Department of Energy Aurora supercomputers. And that look at it is a very, very complex, but on the other hand, it's just a very good package using all the best technologies in packaging that Intel has, from EMIB to Foveros. Advanced packaging chiplet for supercomputers. The Frontier supercomputer at Oak Ridge National Lab is the first exascale supercomputer, ranked #1 on May 31st in Hamburg. But also, it is #1 in green. Isn't it amazing that we have this #1 in supercomputers, in exascale performance, but also it's #1 in the green computer. So on the top right, you see the Fugugo supercomputer that has been the #1 in 2021 and 2020. And that is not exactly the same, but it is also a heterogeneous integration. They are using the silicon interposers. As you can see, 2 HBMs with the processing in the middle. And then you have Aurora supercomputer. Now, I want just to show the report to the president by the President Council Advisors, and he talked about the importance of R&D for CHIPS and Science Act in building the future. Building the future is a broad coalition set up, and the last item they mentioned, set up a national research agenda. So important for us to see that we need to think about the research agenda to build the future. We're at a unique point in time for a global recognition on the critical need of semiconductors and microelectronics for the foundation pillars of the different nations' economy. Immense need for heterogeneous integration technology roadmap to address the ecosystems agenda for the future vision, different challenges. Our grand challenge is ourselves. How do we work ourselves to take full advantage of this unique point in time? If we don't do this in the next few years, the opportunity will be lost. So let's work together and working for the future. Thank you very much.